Welcome to our explainer, where we try to create a blueprint for understanding some pretty complex topics.
You know, Alex, today that's literally what we're doing. We're jumping right into the world of software design and this really powerful planning tool called UML.
Oh man, this question, it takes me right back to a software project I was on a while ago. We just jumped right into coding, no real plan to speak of. And Sarah, it was absolute chaos. You had team members with totally different ideas of what we were building. We kept having to tear down and rebuild features. Nobody, and I mean nobody, had the full picture in their head. What a mess. Oh, I've so been there, Alex. It's so frustrating, isn't it? It's kind of like trying to build a house by just, buying a giant pile of bricks and wood and just hoping it all works out. You'd never do that, right? Of course not. You'd start with a really detailed blueprint. And software? It's exactly the same. It absolutely needs that blueprint to avoid the kind of disaster you're talking about.
A blueprint for software. I love that analogy. I'm totally sold on that idea. So in the software world, does this blueprint have like an official name?
It sure does. It's called UML, and that stands for the Unified Modeling Language. Now, the most important thing to get from this definition isn't just that it's about drawing pictures. No. It's a standardized language. And because it's a visual graphical language, everyone on the project, we're talking developers, project managers, business folks, can actually see and agree on what the system is supposed to be. Everybody's on the same page.
So it's all about creating that common ground. A shared vocabulary, a shared vision for the plan.
Exactly. The source we looked at calls it a standard way to write a system's blueprints, and that's just the perfect way to put it. This blueprint can cover everything from the really high-level business goals all the way down to the nitty-gritty nuts and bolts details of the code itself.
Okay, so a master plan for software. It makes total sense. I'm on board. But here's the thing. I've heard there are just a ton of different UML diagrams. Like, over a dozen of them? That sounds incredibly complex. How do you even start to wrap your head around all that?
That is a great question, and trust me, it's way less scary than it sounds. So yes, it's true. There are 14 official types of diagrams in UML, but here's the secret. They all fall very neatly into just 3 main categories. Once you get these 3 buckets, you've basically understood the entire philosophy behind UML.
All right, let's start with the foundation. The very first category is called structure diagrams. And just like the name says, this is all about the static, unchanging core of your system, the skeleton, if you will.
So these diagrams, they're all about answering one big question. What is the system made of? Let's go back to our house blueprint analogy. Structure diagrams are the floor plans. They show you the rooms, the walls, where the windows go, where the plumbing is routed. They show all the essential parts that absolutely have to be there.
Okay, so if we're talking software, that would be things like the main building blocks, right? The different modules, the core components, how they're connected.
You got it. It's all about defining that core architecture before a single line of code gets written.
So if structure diagrams are the static floor plan, what's next? A house is more than just walls and pipes, right? You need to know what actually happens inside the house, and that brings us perfectly to our second category, behavior diagrams.
Okay, I see where this is going. So this is like describing how people actually live in the house. You know, walking from the kitchen to the living room, flipping on a light switch, running the shower. It's all about the actions, the processes, the flow of things.
That is it, exactly. Behavior diagrams show the dynamic living side of the system. They answer, okay, so what does this thing actually do? They spell out the functionality, the workflows. Like a use case diagram, for instance, is perfect for showing how a person is going to interact with the system to get something done.
Got it. So we have the structure, that's the what, and we have the behavior, that's the how it works. Is there another piece to this puzzle?
Yep, there is one more layer, and it's actually a special kind of behavior diagram. This last category is called interaction diagrams.
So interaction diagrams zoom in and get even more specific about behavior. They really focus on answering how do all the different parts of the system talk to each other to make something happen. They show the flow of messages and data back and forth between objects. You know, a sequence diagram is an amazing example of this. It maps out the step-by-step conversation between different components to complete one single task, like processing a customer's online order. Okay, the light bulb is officially on. Structure is the what, behavior is the how, and interaction is the how they talk. It all fits together to give you this complete picture. So let's get down to it.
What are the big, real-world benefits of actually stopping and taking the time to make these things?
And that really is the million-dollar question, isn't it? What's the big deal? Why bother with all this drawing when you could just be coding? Well, the answer is all about the incredible power that having this kind of blueprint gives you and your team.
This really lays out the payoff. So first off, you get to visualize the whole system before it even exists. That means you can spot design flaws on paper, which is way cheaper than finding them in code. Then, you specify exactly how it's built and how it works, so there's no confusion on the team. That leads to the third point. You can construct it with a clear guide, which means building it faster and with way fewer bugs. And finally, you document the system in this universal language, which is a lifesaver for new people joining the team down the road.
So when you boil it all down, it's about clarity, communication, and, well, efficiency. It takes what could be a totally chaotic process and turns it into an organized, solid engineering discipline. A good blueprint really is the foundation for any good work.
That's it exactly. So the final thought we want to leave all of you with is this one. What's your blueprint for success? Because whether you're building software or tackling any other complex project, taking that time to plan and design up front, well, it isn't a delay.
It's the most critical step you can take toward getting it right. Thanks for joining us for this explainer.